Okay, this question is asking sketch FM of t and PM of t for the modulating signal M of t shown in figure P4.3-7. Given omega c is equal to 2 phi times 10 to the power of 7, kf is equal to 10 to the power of 4 phi, and kp is equal to 25 phi. We had to use this information and draw the FM signal and also the PM signal. Okay. Now let's look at the FM signal, but before that let's note down the given information. The first one given is omega c, that is 2 phi times 10 to the power of 7. Omega is 2 phi f. Okay, so from this one we know that f is going to be just 10 to the power of 7. That is carrier frequency in this case because omega c, so this is fc, 10 to the power of 7 hertz. Okay, that is fc, and then kf is given. That didn't print it properly here. There's 10 to the power of 4 phi. Okay, and also kp is given. That is 25 phi. These are the information we had to use in order to draw the diagram. Now let's look at the FM first. So if you look at the FM, the instantaneous frequency equation for the FM is given by this Fi of t, that is equal to Fc, that is carrier frequency, plus this Kf value, divided by 2 phi multiplied by m of t. And here we have to find out the minimum and maximum in order to draw the graph. So first let's find the minimum. Okay, m of t minimum, and also we have to do the m of t maximum, then we can go ahead and draw the graph. So here to find out the m of t minimum, I mean Fi of t, we just plug in the value. So here fc is we found out that's 10 to the power of 7 here, and then kf is 10 to the power of 4 phi, and then divided by 2 phi, and m of t minimum, you have to see what is the lowest value for the graph. If you look at this one, this graph, the maximum value it gets is 1 and the minimum value it gets is -1. So when we are doing minimum, we have to just multiply by the lowest value, that's -1 in this case. Okay, now let's go ahead and simplify this one. So this is going to be 10 to the power of 7, and then here 5 cancels, and we get plus, actually we get minus because of the minus sign, so we are going to get minus 10 to the power of 4. And if you want to express in megahertz, we can take 10 to the power of 6 common, so that's going to be if I take 10 to the power of 6 common, that's going to be 10 here, and then minus, then this is 1 over 10 will be 1 over 10 square will be remaining, so that's going to be 1 over 100. 1 over 100 is 0.01. okay. So let me confirm this. So 10 to the power of 4, 10 to the power of 7, minus 10 to the power of 4, and if I take 10 to the power of 6, there's 1 10 remaining here, and here we are missing 2 10s, so that's going to be 0.01. Okay, so this is going to be just 9.99 and there's also a 2 dividing. I didn't consider that. So this is gonna be divided by 2. So that's gonna end up with 0.05, something like this, if you divide it. But let's show this one right here. 0.001. If you divide this one by 2, that's gonna be 0.01. Actually, we are dividing by 100, so 0.01. That's gonna be, if you divide by 2, 0.05. So this is gonna be 9.995 megahertz. Okay, that is the minimum of it, and then maximum. Fi of t minimum is this. Fi of t maximum, same equation, only the maximum will be different because maximum happening at 1. So instead of multiplying by -1, we will multiply by +1. So this is going to be exact same equation, 10 to the power of 7 plus 10 to the power of 4 5 divided by 2 5, but this time it's multiplied by 1. So now we are gonna just add them. So here, as after we simplify and everything, we are gonna end up with this 10 to the power of 6, and then 10 minus 0.01 divided by 2, that is 0.005, and here this is going to be plus because we multiplying by +1. Here it's negative because we multiply by -1. Okay, so from this one we will get 10 plus this, so that's going to be 10.005 megahertz. Okay, that's the maximum frequency. Now we can go ahead and draw the graph for this. Okay, for the graph, let's bring, maybe if I can, let's see if I can copy this. Okay, so this is the graph here, and this is m of t graph. Okay, let's mention that. This is for m of t, but we are interested in drawing the graph for fm. So if we draw the graph for the fm, let's align with this graph and show the exact things. Okay, FM graph is going to be just a wave pattern like this. And if you notice this interval right here, at this time this graph is going to be minimum because this is happening at from here to here, this is -1, so this one is Fi of t minimum. Okay, and this one is just the increment, like it's going from minimum to max, but max is not happening yet. So if we take this interval here, this one we can say frequency increases linearly from from 9.995 megahertz to 10.005 megahertz. Okay, that is this part. And if you look at this one, this is the maximum. This interval is the maximum. So we can mention it here, that is, this one is Fy of t maximum, and this pattern keep on repeating again and again. Okay, so that's the thing we had to know. Okay, so that's the first FM graph. Now we had to draw the PM graph. Again, same process, we had to find out what's the minimum and maximum, and then we had to draw the graph. So for PM graph, it's a little bit different. It's gonna be same as before. Like if you look at the pattern here, FC plus KF over 2 phi M of t minimum, but here we had to take the derivative of this one and then take the minimum of it. So that's going to be the difference here. If you look at the instantaneous frequency for the PM, that's going to be FC plus KF over, actually this time is, we have provided KF and KP. KP is for the PM, so this time it's going to be KP. That's also another different. Here in this equation we have KF, but for this one is KP, and that one divided by 2 phi, and then we had to take the derivative of M of t over dt. Okay, and then now let's apply the equation. So Fy of t and then Fc, that is 10 to the power of 7 hertz, so 10 to the power of 7, and then Kp, that is given 25 phi, that's 1 divided by 2 phi, and here for this part the max value of the derivative. Okay, so if you look at the previous one, we just multiply by -1, but we cannot do that because we had to find the derivative of this graph to find the new maximum. So I'm going to copy this graph and see how the derivative of this graph is going to look like. So copy paste and then put it here. Okay, so if you take a derivative graph, that's basically the slope, like slope equation. If you took at y2 minus y1 and x2 minus x1, that's gonna be the derivative. And here if you look at this y2 minus y1, at this point this is -1, so y2 is also -1, y1 also -1. If you subtract them, that's going to be 0. So at this point this graph is going to be 0. If I draw the graph for it, so this is 0 from here to here. Then if you look at this one, starting from -1 to going to 1, and at this time y2 minus 1, y2 is 1, y1 is -1, so 1 minus -1, that's going to be 2. And we are not done yet, because y2 minus y1 divided by x2 minus x1, y2 minus y1 divided by x2 minus x1. x2 in this case is, okay, let's look at this one. This one is easier because this same pattern reoccurring again and again. So if you look at this, x2 is in the a distance, and if I consider this as c 0, so a minus 0. Okay, so this is going to be 2a, actually 2 divided by a, because y2 minus y1 over x2 minus x1, that is 2 divided by a. Okay, and then again here y is same value, so y2 minus y1 is 1 minus 1, that's going to be 0. then at this point you see this is going downward, so slope is negative, so this is going to be the square diagram but downward because of the slope is negative. And this pattern is going to keep on repeating, and this guy height is y2 minus y1 over x2 minus x1, that is in this case 2 over a, and this is minus 2 over a. Okay. So now we have the idea of what is the max and minimum, because maximum is the highest value, minimum is the lowest value, and also we can point out the intervals. At this interval is 0, at this okay. Okay, this at this point also this is 0, and at this point is the minimum like this. Okay, so this is gonna repeat again and again. So we just need to know what is the maximum, that is this, and what's the minimum, that is this. So once we found that, then we can find out the minimum and maximum. So let's find the minimum first. Minimum, where is the lowest value? So where lowest value, you can see minus 2 over a, so I put that one here, minus 2 over a, minus 2 over a. Okay, then here 5 cancels, and then 25 divided by 2, and then that one multiplied by negative 2, so the 2 cancels as well. So we are going to get 10 to the power of power 7 minus 25, and that is it. Okay, and then let's see if I can simplify this one in a better way. And also there's an a left, 25 over a. Okay, and here another thing we can consider, we don't have a value, like currently a is just a constant, like we don't know nothing. But here if you look at this given diagram, we have 10 to the power of minus 3. Okay, that is period. So t is 10 to the power of minus 3, and a period contains 4 a's. If you look at this pattern, starting from here and ending at the same location. So this is one period and one period is 4a. So therefore 4a is 10 to the power of minus 3. Therefore a is going to be 10 to the power of minus 3 divided by 4. So we can apply that one instead of a. So 10 to the power of 7 minus 25. Instead of a, I put 10 to the power of minus 3 divided by 4, so that 4 multiplies here, and we are going to have 100 on top, and also 10 to the power of minus 3. So 100 plus 10 to the power of 100 and 10 to the power of minus 3, that's going to become plus 3 when it goes top. So plus 3 times plus 2, that's plus 5. Okay, we have this one. Okay, we have this one. Now we can express this one in a better way by taking 10 to the power of 6 common. So that's going to be 10 here, and then here this is going to be 0.1 in this case. So that is 9.9. So we can say 9.9 megahertz is the minimum. And maximum is going to be plus, that's it. So you can rewrite everything and do that, or just directly, if I do it in a site, because in the maximum we will be multiplying by positive 2 over a, so we will be end up getting the final thing as positive, that is 10 to the power of 6 10 plus 0.1, and that's going to be 10.1 megahertz. Okay, so from this one we have the maximum and minimum, and we can go ahead and draw the graph. Okay, so this is again is going to be a repeating wave pattern. Okay, this is for the PM, and we have to look at each interval. So at this interval there's nothing, so this is going to be just carrier frequency at this location, FC. And at this location, you see at this interval this is at the max, so this is Fi of t max. And at this location you see nothing again, so that is also carrier frequency. And from here to here this is at the minimum, so this is Fit of min. Okay, and that's basically it, and that's how we draw the FM and PM diagram. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.